Well, thank you very much for allowing me to be here. It's my pleasure to be included amongst so many great speakers. And whereas we just heard about building better brands, we're going to take a little bit of a switch. Instead, more of what I talk about has to do with maybe building a better brain. And so, we've made huge advances within the field of cognitive neuroscience, where we've been able to study things like the structure of the brain. So every brain is different. One of the first things that really struck me when I started scanning brains using MRI scanners was, well, first, it's amazing. You're talking to somebody, and 4 minutes later, you're tracing blood vessels through their brain. But the other thing is that everybody's brain looks different. Right? Nobody's brain looks the same, which maybe shouldn't have been such a shock. Our fingerprints are different, our faces are different. But it was. We have these individual differences. And those individual differences in brain structure lead to individual differences in brain function, patterns of activation. But most importantly, with advances in things like magnetic resonance imaging, you can see up there the big hairdryer looking thing there is magnetoencephalography, looking at changes in magnetic fields that correspond to neural activation, electroencephalography. We even have down there, you see this little thing over somebody's head. It's called transcranial magnetic stimulation, where we can momentarily disrupt brain function to be able to look for the causal role of different areas of the brain and what they do. And without going into a lot of detail about, all these techniques and how they work, the bottom line is that we've learned a great deal about how the human brain works. Huge advances in terms of learning things like different areas of the brain contribute in different ways to different abilities. So you've got things like the hippocampus, which is really critical for memory. The amygdala, which plays a key role in emotional responses. And again, I'm not going to go through the whole neuroanatomy and Psych 101 in terms of connecting these things, but this is an important point. This idea that different parts of the brain contribute in different ways, contribute signals according to what they're specialized to do. The reason why this is important is because you need to remember and keep in mind that each of these regions is doing what it does, and it's producing a signal. And each of those signals then are competing. They're competing to become the focus of your thoughts and your actions. And the reason for this is because our brains have a fundamental limitation in the amount of information that we can be consciously aware of, the amount of information that we can direct our responses to. And so because of this constant competition, well, we have to find some way to be able to resolve this competition. We have to find some way to be able to prioritize what are the things that we're going to respond to and what are the things that we're not going to respond to. And this is where we have things like attention, cognitive control. These circuits within the brain, they tend to be on the top and outermost parts of the brain, in the cortex, the outer sort of wrinkly covering of the brain where most of its computational power is. And these regions serve to effectively turn up the volume on brain signals that are relevant to the task at hand and to turn down the volume on signals that are irrelevant or unrelated. And so this allows us to, interact with our environment in fairly seamless ways where we're able to, pick up on things that are really important to us and to be able to avoid being distracted by other things. So far this is talking about attention and cognitive control. So what does this have to do with great ideas? Well, let's think about this whole theme of this conference. This get-together is about what's next, which is basically about innovation, right? We've got these changing demands. We've heard a lot about, rise of mobile internet and different challenges within the marketplace. So how do you come up with the next great event idea? Maybe how do you better connect with donors? Lots of leaders in this room. We heard a bit about the difference between management and leadership. So how do you become a better leader? How do you become more inspiring to the people who report to you? Well, all of these things basically are about solving the problems that you have at hand while also trying to anticipate the future. And this requires insight and creativity. So now I've told you about attention and cognitive control, helping us to be able to focus on things that are relevant. So then, the question is, how do you make the breakthroughs? How do you come up with the next big thing within fundraising arena? Right? So we can talk about maybe you need a more focused approach. Maybe you need to, have stronger concentration on things that are relevant to the future. Eliminate distractions. Don't get spread too thin. All of these are potential candidates, but I'm going to tell you instead that these may actually be counterproductive for coming up with truly revolutionary ideas. So why is this? Let me tell you a little bit about this network within the brain that's really important for our ability to make associations between different things, between different objects and places and events. So you can see here, this is a medial view of the brain, so straight down the middle, and what is highlighted there are these swaths of area within the brain that are, in some ways, it was a bit counterintuitive when this was first discovered, but they're more active when you're not doing anything than when you're actively engaged in a cognitively demanding task. And the mystery here for people who were initially doing these neuroimaging studies was the fact that, well, to do a neuroimaging study, if we want to look at which part of the brain is involved in memory or reading or paying attention, we design a cognitively demanding task that you read in or pay attention to something or remember something, but we have to compare it to something. Because a key principle about the brain is that the brain's always active. This idea that you're only ever using 10% of your brain is nonsense. Your brain is a hugely metabolically active organ. It's always active. So what you see when we show you these maps of the brain with these hot spots, those are relative increases in activation, and often only 1 to 3% at that. So what we see here, the baseline, was often we'd tell people to lie on their back and look at a little fixation cross and don't do anything. But of course, when you're not doing anything, you're actually doing a lot. You're thinking about what you did last weekend, or you're thinking about what you're going to do next weekend, or where you're going to go shopping, and the fact that maybe I'm not going to go to that grocery store because I ran into that bonehead last time, so I'm going to go into this other place and hopefully avoid that awkward confrontation. And, speaking of confrontations, I've got to deal with this. It's this freely associative, one idea leading to the next, right? So this is what's known now as the default network. Part of the brain that is active when you're not actively engaged in some sort of externally demanding task. And there's a few things that we've learned about this default network. So what is it, this freely associative thought? Well, it's things like daydreaming, things like planning. What are you going to do tomorrow, next week? Thinking about the past, or thinking about social relationships, right? All of these things that are really important for you, but these aren't things that are necessarily tied to some external event. These are internal representations. So in fact, this network of brain regions, when it becomes active, is allowing you to ponder and to reflect and to go over things that are important to you. Right? We see overlap between this default network with things like autobiographical memory. Why is it as you take a trip down memory lane, thinking back to when you used to go to Sunday dinners at grandma's house or whatever that is, well, that mental trip that you take involves parts of the default network. Same thing when you're envisioning the future. Instead of thinking just about the past, thinking what's going to come next. And here's an important point about the way that the memory system within the brain is organized. In fact, increasingly, we're thinking of the memory system within the brain not for our ability to reflect on things that we've done before, but instead to be able to anticipate the future, to be able to prepare us to facilitate our ability to make predictions, to be able to know what's going to come next. Because if we know what's likely to come next, we can prepare for that and be able to respond to those situations more effectively than we would if we didn't have that information. In theory of mind, thinking about what other people are thinking about, their perceptions of you and your relations with them. These are all components of this default network. There's another important part about this default network, and the different components of this default network, this internal train of thought, is that if you have some externally demanding task, it turns off those brain regions. Remember, what does attention and cognitive control do? Well, it helps you to prioritize things that you think are really relevant. So if you've got some task that demands your attention to something out there, a conversation, walking down the street, avoiding getting hit by a car or something like that, well, that requires your attention out there, which means that you end up turning down the volume on the brain signals from other areas of the brain that are less related to the specific task at hand. And conversely, when attention is less focused on something that's out there, we take a broader focus, well, now we see activity within these different regions being able to return and come back. So this is important and really a big part of what led me to think about this. It turns out I wasn't the first one, but I thought I was. This kind of conundrum. I've got an office that, thanks to the taxpayers and other people within the university, I've got a fabulous office. Nice computers, great big screens. I've got a laboratory with tens of thousands of dollars of equipment, and all of this is for innovation and basic discovery and research and the next big thing. And I spend an embarrassing amount of time staring at my computer screen in these situations, despite having all this great equipment. And yet, within the 5 minutes that I spend in the shower, I will somehow plan my day, solve 3 problems, and know what I'm going to do next. So it's this conundrum, what is it about being in the shower that, at least for me, is a hugely productive period of time? And so this, in part, and just as an aside, this is one of the few places, or one of the first places, where I found a real good use for Twitter. Right? When I helped to write The Winner's Brain, the publicist said, well, you really need to get on Twitter. It's going to be important for connecting to people and letting them know about your book and other things that are going on. And then I got there and basically saw a lot of people saying things like, I like butter. I like butter too. You know, sort of these inane things. But when I came with this idea about, why is it that I get these great ideas in the shower, I went and searched best ideas shower within Twitter, and I was amazed. Thousands of people who, amongst their I like butter and you wouldn't believe the cool shoes I got today, are talking about things like, I can't believe, I don't know what it is, but I get the best ideas when I'm in the shower, or when I'm jogging, or when I'm doing the dishes. What's unique about these things is it's not when they're doing something that's related to the task. It's not, I get the best ideas when I'm sitting at my desk focused on the task at hand. It's when I'm doing something completely different. So why is this? Well, in part, it's because when you're in the shower, or when you're jogging, or when you're doing the dishes, or vacuum, or anything like that, you're doing a task that isn't very demanding. Slightly demanding, but not very demanding. So what does that do? Well, that allows you to loosen the reins, because you don't have anything that you really have to narrowly focus on. So it loosens the reins of cognitive control and now allows brain signals from these other brain regions that otherwise wouldn't be allowed to sort of simmer and have their input. And that's important when we talk about creativity and insight, because what is innovation? What is creativity? It's about our ability to realize or to make connections, see associations between things that otherwise we or everybody else see as being completely unrelated. So if you're doing some task-focused activity and you don't see this as being definitely related, you're going to tune out those brain signals. Something like being in the shower, jogging, well, this gives you time to mind wander, allows these brain signals to sort of come through and allows you to make these associations. So we get these increased contributions from this associative network, parts like the default network, that allow us to make connections between these things and to have these creative insights. And there's no shortage of examples of these things. George de Mestral, probably everybody knows, the inventor of Velcro, had his insight. He saw a thistlebur sticking to his dog's fur, and that's what led to the development of Velcro. Newton with gravity, sitting out in the orchard in Apple Falls. Lots of these things. Einstein apparently was said to get his best ideas while he was shaving. So again, all of these are situations where it's not a task-directed activity, doing something completely unrelated. So in fact, all of the things that I suggested before about, increasing your focus, better concentration, resisting distractions, in fact, all of those can be counterproductive to being able to come up with creative insights. But some other examples where we have cognitive control that's turned down that allows for creative expression. When you turn down cognitive control, now this allows you to be able to flexibly recombine representations that you have of past experience. And this is the important part. I'm not suggesting that we all quit our jobs and spend all day in the shower, right? As nice as that may or may not be, right? You need to put the initial time in with the problem. You need to gain some expertise. You need to get your brain so it's in that state where it is actively thinking and working on a specific type of problem, right? And the value then comes when you give the break afterwards. So we see this great example of this is a study, an fMRI study on jazz improvisation. So what Lim and Braun did is to take people who are very good at improvising jazz pieces, and their innovation was to come up with this keyboard that they could put into an MRI scanner. Normally, that wouldn't be allowed because you're not allowed to bring any metal into the MRI scanner. And what they had is these individuals to play a tune, either from rote memorization or to take and expand on that theme and to improvise. And that contrast, you can see, is shown here. The most remarkable thing about this is that these cognitive control areas, these areas that normally allow us to coordinate different mental processes, that's what you see there in blue-green. So you actually see a reduction in cognitive control in these prefrontal frontal cortex areas that you do compared to this rote memorization. And they interpreted this result as being that, well, here you have people who have a certain level of expertise who now are able to capitalize on that expertise without having too much of this self-critical monitoring activity that normally we would see in the frontal areas. And so this relates to something that we heard earlier today from Kevin talking about not being afraid to take risks, right? When we're coming up with ideas, we have brainstorming sessions with people, we're often a bit self-conscious about the things that we're going to say. That is part of what inhibits your ability to make these sorts of associations. When you're able to turn down activity from those sorts of areas that are responsible for you worrying about what you look like and being self-critical, if you can turn those down, well, now you're able to get a little more risk-taking, a little more free expression, and better results. So the take-home message from this is that sometimes we can try too hard. And we really want to come up with what's next, be the next innovator, that sometimes trying too hard can be counterproductive. Focusing too narrowly then can suppress these brain signals that can really help us out in other situations. And so now there's a lot of research that shows that a slight distraction can actually help us out. So in my case, it was being in the shower. For other people, doing the dishes. Here's a great study. This just came out a month or two ago, some work by Ben Baird and colleagues that's looking at this task. It's called the unusual use task. And so things like, tell me everything that you could do with a shoe. So here we have an unusual use of a shoe as a hammer, and it's an index of creativity. The more of these options, unusual uses for an object, it's an index that you're able to come up with some creative solutions to things. And what they found is that if they first do this task, get a baseline of what their performance is, and now give a break. And within that break, you have people either do a slight task, so just enough to keep them busy, but not very cognitively demanding, not the sort of thing that you really need to focus so narrowly on that it's going to suppress these brain signals from other areas. Or they had a demanding task, the sort that really requires you to be able to focus and think about what you're doing and comparing it back to what you've seen before, or they just had a rest. We've heard about things like incubation periods. Well, if you just take a rest, take a break, that's going to help out. In fact, what they found is that that wasn't very effective. What wasn't effective, and a 40% improvement at that, was this task where they're doing something that just barely kept them engaged, but not enough to be able to suppress these creative brain signals. So what's another type of distraction that we see that can be helpful in this regard? Well, fidgeting and doodling. Right? I'm a professor, and I teach, for better or worse, research methods, which is really important. The material that we present here is very important for people being able to understand where research comes from, for their eventual ability to conduct good research, to get valid scientific results. But it tends not to be very engaging. And at first, I used to see people, fidgeting and squirming, and every time I start talking about things like my 2x2 factorial design, eyes glaze over, and they start squirming a little bit more. And it used to drive me crazy, because I'd be like, do you know how much time I've spent preparing this lecture? Could you just sit still and pretend to be interested in what I'm teaching you here? But now we understand that actually, a bit of fidgeting, a bit of doodling, actually serves just like this slight distraction. Takes their mind off how mind-numbingly boring what I'm saying is, and actually allows them to take in more of that material than they would if they're forced to sit still. And there have been studies now with school-age children that shows the same thing. Force them to sit still, they do worse than if you give them sometimes even a little fidget toy to play with. So all of this, the take-home message here is that our prior notions of inattentive behavior, mind-wandering, fidgeting, doodling, that actually these can facilitate insight, that these can actually help us to be more innovative and to solve some specific problems. So when we talk about making critical breakthroughs, Again, that initial experience with the problem, very important. Getting the mind engaged, getting yourself thinking about those things, but then to give yourself a break and to provide a slight distraction can be very helpful. And we can think about some of the good types of distractions that are going to be helpful. So for a lot of people, going jogging or engaging in some other physical exercise, can be beneficial not only to give you that break, but because of the vast benefits, brain-based benefits that physical exercise has. The release of these neurotrophic factors, brain-derived neurotrophic factors, which helps you to form new connections between different brain cells. You get new neurons being generated in areas like the hippocampus, which is critical for memory. Or getting out into nature. Huge literature now and growing, showing the benefits for why is it good to go for a walk in the park. It's more than just to get a break from the office. In fact, there's lots of great things about getting out into nature, specifically, again, about the attention system. Being able to have better attentional control, that getting out into nature is basically a way to gently engage the attention system without forcing you to focus too narrowly. Urban environments, honking horns, loud, lights blinking everywhere, those sorts of things very strongly in this bottom-up, stimulus-driven way capture our attention that we have to continually refocus back to what we're thinking about. And that can impair our ability to be able to have insight and creative solutions to things. So all of these come down to this basic point, which really over the last few years has taken up a lot more of my energy, where instead of just spending all of my time in the lab or in the classroom, we come up with these great scientific discoveries that we publish papers and that maybe 10 or 20 of our dearest, closest colleagues read and pat each other on the backs and think we're doing well. But the bottom line is these things are important and they have important implications. And so part of why I'm here is to try to help people to understand that it's important to be thinking about your brain. That in fact, by doing that, allows us to be proactive in shaping how your brains function and ultimately in seeking ways for us to be more successful. So whether that's for the next big thing, these breakthroughs, things of, other forms of focus, drive, all of these important things, the bottom line here is that by understanding a little bit about how your brain works, that can help you to better develop and care for it, and ultimately be more successful. Thanks for having me.